Let's do a brief break-even analysis example. So this is what it says. Two new rides are being compared by a local amusement park in terms of their operating cost. The two rides are assumed to generate the same level of revenue. The Tummy Tugger has a fixed cost of $10,000 per year and variable costs of $250 per visitor. The Head Buzzer has fixed cost of $4,000 per year and variable cost of $4 per visitor. Find the break-even number of visitors per year for the rides to have equal annual costs. And B, develop a break-even graph that illustrates the following. Accurate total cost lines for the two alternatives. You're going to show lines, slopes, and equations. The break-even point for the two rides in terms of number of visitors and the range of visitors per year where each alternative is preferred. Okay, so part A. So let's come up with an equation to describe the Tummy Tugger and one for the Head Buzzer. So for the Tummy Tugger, we were given fixed cost of $10,000 and a cost of 2.5 for every visitor. We're going to call X our visitors. And for the Head Buzzer, it costs $4,000 in fixed cost plus, this is a plus. My screen gets funky all the way at the top. Anyway, plus 4X. So how do I find where X is equal for both of them? Well, I'm going to set them equal to each other. That means 10,000 plus 2.5X is equal to 4,000 plus 4X. If I solve for X is going to give me 4,000 visitors. At 4,000 visitors, both of these options are equally good, or equally costly in this case. Okay, so let's draw our graph. Our graph is going to look like this. Now, I know it says accurate, but I'm not going to be very accurate, mostly because it's kind of difficult to do a lot of accuracy with this kind of screen. But if I would expect that you would be able to do a much better job. So, what is the line for the? Oh, let's first begin by drawing my. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so each one of these, let's say, is 1,000 visitors. So on and so forth. And let's say that each one of these lines is a cost of 2,000. So that's 4,000, 6,000, 8,000, 10,000. All the way till, let's see, 12, 14, 16, 18, 20,000. Okay. Now, the equation for the Tummy Tugger is going to look like this. We're going to, and I'm going to choose a different color. Orange would work. So the Tummy Tugger will be orange. We start at 10, and then for every for every, let's say, 1,000. So how do we find some good points? So 10,000 plus 2.5 times 1,000 is equal to 10,000 plus 2,500. So this is going to give me 12,500. So if I want to plot this, it would be somewhere around here. And if I did 2, you know, this is going to be a straight line. So again, this is a part where the accuracy I requested is not going to be excellent, but you know, we'll make it work. So that's how it would go. All right. So if I do the same with the Head Buzzer, 4,000 plus 4 times 1,000, this would be equal. So with this line, and I should have done it with a different color. I'm going to do it with a different color now. Green. So the Head Buzzer will be green. This is going to be equal to, so if I have 4,000 plus 4,000, this is 8,000. And this would be, so if we start here, then we go here, and hopefully you can see that the line here is going to be steeper, so that if I play my cards right, we should, okay, so 1, 2, 3, then we should be meeting in lines here. So this one is steeper, but right here we have our break even. So that's what this looks like. And this is the thing. So part C is asking me, what are the ranges? So if I have less than, if X is less than 4,000, meaning if I have less visitors, remember that these are costs, so I'm actually going to want the cheaper one. So the cheaper one from 0 to 4,000 is the head buzzer, right? The green one. While from where X is greater or equal to, I guess, 4,000, let's go for the tummy tucker. Did this make sense? Okay, great. Okay, so we're going to talk about this in the next video.